All right, sounds good. So we'll be doing a little short-ish 30-minute talk about cross-chain, building on cross-chain protocols, etc. It's going to be me. I'm a core contributor of QiDao and Pablo, the penguin, and Sam Friedman. He's right here. He'll be hopping on in a minute. So overall, this is a little quick outline of what we're going to be talking through. Effectively, what are we in terms of DeFi, lending protocols of different kinds. There's a ton of different assets, and not all lending protocols are kind of built equal. And kind of go from there into what is the cross-chain protocol and how can we make them work. And then a little bit of how we are interacting today, and then how we're using CCIP, the Chainlink's cross-chain interoperability protocol, to be able to interact between the different chains based on the initial architecture that we have. And then a little visual explanation on that. So for starters, when you're building on cross-chain, you have to look at different features. So a feature is something like a swap, a lending, a borrow that you do that affects the users, lets them do something. You want to make sure that it punishes dishonest activity. And that activity could be borrowing too much or borrowing too little. Now, that could come with different array of effects. Like if you borrow too much, you can't liquidate, your protocol goes into bad debt, and people come yelling at you that you took their money, and etc. Or too little, and the protocol has a lot of dust that isn't able to be controlled or managed by the DAO because it's just ineffective to transact. So a couple of examples are slashing in proof of stake and over collateralization in the lending protocols. As you can see, the little buffer is what provides the bonus to encourage the process of liquidation. Otherwise, if there's no bonus, there's no reason for somebody to just take that collateral. So all of that falls into the game theory and the design of your protocol. So you're looking at different parts and seeing how they can interact. One of them, major one, is the arbitragers. So a liquidator comes in, takes a collateral, pays back some debt denominated in DAI or MAI, depending on the protocol, and they're able to take that collateral. Now, this is being evolved as we, in the last few months, you've heard of CRV-USD, pretty awesome protocol. At the end of the day, what it does is take away one extra step. Instead of needing an arbitrager and a liquidator, you just need an arbitrager by plugging it directly into the AMM, or the automatic market maker. So now when we go into lending, you have a variety of different lending protocols. You got different synthetic types of assets where you have positions that can be taken within the protocol, and those positions are synthetic. You can't touch them. So for example, on Gains or GMX, you can take a position 50x on ETH. You can't take that 50x and drop it somewhere else, say on Aave, and earn liquidity or earn interest. But on Aave, for example, you can deposit ETH, take USDC, and you can take it and LP on Uniswap. That's the difference between a synthetic and a genuine position. And then you have pooled and isolated, where pooled means that all the assets are kind of in one general group. See Aave, where all the ETH, all the USDC, all the DAI is technically pulled together, versus in other protocols like Synthetics and QiDao, where the pools are separate and isolated. So when you borrow one thing, that's one loan, and it's not grouped together with your multiple loans. So then we have the other dimension, which is kind of what we're here for, cross-chain. So in cross-chain, there's many flavors, and a lot of people like to kind of categorize them in one way or another, but it really kind of boils down to how much interaction happens across the chains. You got simpler deployments, which are independent of each other, such as Aave on Compound, where your position does not necessarily affect between the different chains. So if you have a loan on Ethereum and a loan on Aave, on Polygon, they are independent of each other. They don't interact. but you're still able to take the asset and move it around. Now, when it comes to cross-chain, there's this connection. So you could potentially borrow my on Polygon, then take it to Optimism and repay your loan. That effectively makes the protocol itself cross-chain. There is the potential of omni-chain, which hasn't really been explored about except in marketing speak, to make a protocol truly omni-chain. And when I say that, it would be you have collateral on Optimism and collateral on Phantom, and you use that to generate a loan that maybe is represented in Optimism. That's kind of the future. We see that a lot with the plans with Matic, with the value layer of the internet, with base chain and Optimism. It's going to be a lot more cross-chain interaction, and that's when we'll see a lot of that play out. But until then, there's not a lot, not any that are fully available. So a little bit about QiDao. We're a cross-chain protocol for stablecoins, where you can borrow MAI, mint it through depositing other collaterals. Here's a little preview of the different collaterals you can access, how much exposure you can get per asset, and these, as I said before, they're isolated. And the mechanism we use is over collateralized lending. So effectively, you have to deposit a little bit more than what you're borrowing, and you can now have access to that MAI while you have an asset earning yield. Bit different than, you say, your typical Avid position where you have native or vanilla DAI and you borrow against it. Here you can borrow something like DDAI, which is in gains earning an interest, but now you have access to the underlying and maybe you want to do something with it. An easy way a lot of people do, financial advice, but you can deposit this, keep it as kind of a savings account, and then take the MAI, sell it for USDC, and you still have extra working capital. The robustness of the system was proven a few months ago with the V2 version, which we launched last year, where USDC depegged, bringing down all the stablecoins, including GDAI, and people were still able to liquidate through a different mechanism. Now, those mechanisms are all backed by Chainlink. We use Chainlink in everything because it provides a nice base layer of trust. There's liquidity management, there's tracking of the prices on every single chain that they can be on, which is big enough that it's way harder to attack and pump. As you can see, all these variables here are generated through the Chainlink Oracle. There's a lot more data than a regular user may need to see, but it's really you're really able to see exactly how much you owe, what's the discount based on the MAI price. If the MAI price goes up or down, you might be incentivized to repay. We show that as well, and your ratios. So MAI is the stablecoin that we mint through, any user can mint through QiDao. And it's, in general, there's the engine, there's the canonical token, and lastly, the governance module. So on most chains that we're on, about 23, 24, we are at level 1, which means there's liquidity for MAI, and there's a way to bridge, sometimes 2 or 3. And the second part is the lending engine, using Chainlink oracles to enable users to mint that MAI. And the third one being, once we're big enough within a chain, we're able to deploy our governance modules and effectively let the user start controlling directly the chain. So, as I said, with the level 1, token bridging is a very integral part of this strategy because you want to have MAI and you want to have it anywhere you go. You want to farm it on a random chain, you're welcome to. You want to farm it on Optimism, you can. You want to trade it or leverage it or do any perpetual positions, you can. But to get there, you need bridging. And that was something that initially we decided that it's not something that it's in our purview or our business. So we came up with a solution called the canonical token bridging, which enabled us to be on multiple chains without relying on a single bridge. You may hear when you talk to a bridge, they say, go with us, we'll launch your token on another chain. Now, the underlying issue and the second order effect of that is they control your minting. So if there's another bridge that you want to integrate, you can't. That bridge controls your mint and burn. So by being able to create MAI on every chain ourselves and then providing synthetic liquidity to the bridge, we're able to close that risk. So if in case something happens, for example, in multi-chain, we're able to remove that liquidity, then we can talk to other bridges such as Axelar and Stargate, which we did in the last 6 months or so. And we were able to move a lot of the liquidity to these new bridges and able to upgrade the system, which enables us to continue working, which a lot of different protocols weren't able to do so and didn't have the ability. So now they're forking or doing airdrop to kind of move away from that model. And yeah, a little more reiterating the importance of bridging. If you want to survive more than 5 years, you got to know how to upgrade and what can you do to upgrade, because if you don't, and you don't plan for that, it's not a good time. So the role of QiDao, just reiterating a little bit about what we do and the stable asset nature that we want to provide. Users don't necessarily have the ability to access USDC on certain chains. They can't mint it directly. That opens up a lot of issues, because now if you want to have USDC on your layer 2, you have to go to Ethereum, mint it through Circle, and then bridge it. Now it's available on a few other chains like Polygon, but still not available everywhere, which effectively is a bottleneck for a lot of chains to kickstart their capital and enable better money markets. And now going to the governance side of QiDao. A lot of our governance is done through Snapshot, and we use that to collect all the signatures, get people voting. Behind the scenes is voting escrow Chi. So effectively you're locking Chi for a period of time, minimum a week or 2, up to 4 years. And that enables you to have a higher voting power. So with that comes the multisigs. So we have 3 main multisigs that control the different aspects of the protocol. For starters, we got the Guardians. The Guardians control the vaults. The vaults are each isolated lending market on every chain. And also the My Contract, which interacts with the bridge pools. The bridge pools could be Axelar, it could be something else like Stargate, and other bridges, depending on something happens, we can remove it from there, put it elsewhere, and the Chi contract. So all this is managed by the Guardians, which then the fees generated get put into the QiDao treasury, which is technically, I believe, 1 or 2 contracts, if I recall. And the idea is to separate the management versus the ownership. Ownership being, do we need to change the oracles? Do we need to update any vault parameters? All that is separate. And now, how do we bring this and make it more anti-fragile? You got a bunch of multisigs. What happens if something goes wrong with a signer? They lose a ledger, they lose their seed phrase. How can you continue running? So that's where we can bring in CCIP. So we've explored the idea of how to break a multisig in modules a few months ago, effectively trying to bring the time locks into the multisig. So if there's one signer, at least one of them alive, they could submit a transaction and take a predetermined amount of time, say 2 weeks. You could have that one signer rescue the funds of the multisig and basically have administrator control after a long period of time, so that in case something happens to the signers, you're still able to access the funds and continue running the protocol. Now, that opens up the door for Chainlink, which we'll bring in a second. The idea is that with Chainlink, you're able to now send a message to the other chain, the different deployments, and basically interacting the same model of the time lock, but using CCIP, which Sam will tell us a little bit more about.
Thank you. All right, I'm a footnote, the human footnote. Thank you. So I've got about 5 slides. I'll cover Chainlink cross-chain interoperability protocol at a high level, also a low level. Any developers here? Yeah, okay. Awesome, I've got stuff for everyone. So Chainlink CCIP has been in development for over a year. Finished alpha testing at the beginning of this year. QiDao is one of our alpha testers and a launch partner. And then we've been beta testing since since February of this year, all kinds of use cases. What CCIP is a way for protocols to build cross-chain capabilities into their processes, whether it's token transfers or message passing, to support use cases like governance or balancing liquidity, etc. We'll go over use cases in a bit. The way it works is a sender on a source chain, which might be an externally owned account or a smart contract, can send a message to an account on a destination chain. And that message can include either tokens or data or both. And data is just encoded bytes. So it might be a simple string, like a message like hello world, or it might be some operational code or instruction that instructs the receiver on the destination chain what to do with the tokens when they arrive, or what to do with the data when it arrives. A little bit of code. I'll go kind of quickly. The way the sender's experience is every chain that CCIP supports will have an immutable router contract on that chain, smart contract on that chain. And that contract has a function called CCIP send. And it takes two inputs. One is the ID of the chain, of the destination chain, and two is a message. And that message is a data structure that includes the receiver, so the address of the receiver, the data that's being sent, which is optional. You can just send tokens with no data. It optionally includes an array of tokens, so token addresses and the amount for each token. Then the fee token. So users pay to use CCIP, and payments can be made in either the native gas token, the wrapped native gas token, or the link token. And then lastly, there are some optional arguments that the user can set that determine how, if all messages are delivered in sequence by default, but if strict sequencing is set to true, then if a message gets stuck, then future messages are held until the stuck message is fixed. So we've got workflow around that. And all fees for CCIP are paid by the sender. There's no fee extraction from the receiver, which means the sender needs to be able to estimate how much gas will be spent on the destination chain. And that's one of the arguments that the sender can set. So that's the whole sender's experience. One quick item is, if you look at the name of the structure, of the message structure, in this case, it's EVM to any message. EVM means this is from an EVM family of chains. And to any means any other type of chain. Doesn't have to be EVM. So the sender's experience from an EVM chain is exactly the same, independent of what the destination might be. So if you're sending from Ethereum to Avalanche or Ethereum to Solana, sending the message is exactly the same. On the destination side, if the message only contains tokens and there's no need to process an incoming message, then when the message arrives on the destination chain, the tokens are just sent to the receiver's account. However, if the receiver wants to process a message, because maybe there's data in the message, or there's data and tokens, and the data is instructions on what to do with the tokens, then the receiver is going to be a smart contract, and it's going to want to implement our receiver interface and the CCIP receive function. The router on the destination chain calls the receiving smart contract with a message, calls CCIP receive on the smart contract, receiver smart contract with a message. And that message includes all the stuff you would expect, all of it which came from the source. So one is the message ID, which was calculated on the source. Then the sender, the source chain ID, the sender's address, any data, if the sender chose to include data in that message, and then that array of tokens. And then it's up to the receiver to put whatever logic they want in their CCIP receive function so that they can maybe process data or do something when the tokens arrive. All right, so a little bit of a deeper dive into our architecture with a focus on security. So this is really the same slide as this, but I'm opening up this black box right here. So on the source chain, we still have the router contract, the immutable router contract. which goes to an on-ramp contract. There's a separate on-ramp contract for every supported destination chain. And then there's a token pool contract for every token we support. And the token pool contract, well, let's start with their on-ramp contract. The on-ramp contract would just check things like, was the receiver's address specified in the correct format for this destination chain? The token pool contract would have rules like, what's the token handling mechanism? Are we burning the token on the source or locking the token on the source? It might also have security rules like rate limiting. Maybe this token issuer doesn't want to allow more than $100,000 worth of value to be transferred over this particular lane, source destination, within a small time frame like 1 hour. So the token issuer can set rate limits and protect themselves against things like infinite mint attacks. After the source chain transaction has been finalized and an event has been emitted, then we have some off-chain work. The first thing that happens off-chain is there's a committing DON. DON is a decentralized Oracle network. It's the same application architecture and network that supports our price feeds, our automation functions, our other Oracle services. The committing DON takes a snapshot of all the finalized transactions within a certain time frame for a particular source and destination chain. We're going to get a little technical here. Creates a Merkle tree and posts the Merkle tree root in a smart contract on the destination chain. And for those that don't already know, a Merkle tree is a data structure that lets you summarize all the elements in a set with just one value, like a hash. And it's cryptographically secure. So the committing DON posts this proof on the destination chain of all the transactions that are finalized on the source chain. After that happens, we have a separate network called the Active Risk Management Network that does the exact same thing and compares the Merkle tree root that it calculated with the one that was published by the committing DON in the commit store. If they match, that's great. The Active Risk Management Network will bless that Merkle tree root or bless that proof. After that happens, we have an executing decentralized Oracle network that can relay all the messages from the source chain to the destination chain as long as it has a valid Merkle proof of that transaction. So we have 3 different networks of nodes, of Oracle nodes, all involved in securing the network. And 2 of these decentralized Oracle networks, the committing DON and the executing DON, are the exact same technology that's been securing our price feeds for the last 4 years, our automation Oracle, our functions Oracle, our proof of reserves Oracle. So there are no new trust assumptions when using CCIP. The architecture is the same as all the other products. The technology is the same as all the other products that we've been supporting over the last few years, securing trillions in transaction value in DeFi. On the destination chain, when the executing DON submits their proof with a message, that message goes to the off-ramp. And if the message contains tokens, is checked against the token pool. The token pool, again, would have rules like rate limiting, token mapping. This token address on the source chain maps to this other address on the destination chain. Rate limiting and the token handling mechanism. So are we unlocking a token on the destination chain, or are we minting a synthetic version on the destination chain? And then when that's completed, the message goes to the router, which is that immutable smart contract, which sends the tokens to the receiver, and then optionally calls that CCIP receive function. All right, that's it for architecture. So some guidelines, security guidelines when we design the system. One is we're using the same network architecture processes to secure and build CCIP as we have for all of our other products. So there are no new trust assumptions when using CCIP. If you're already comfortable with our price feeds, then you should be comfortable with CCIP, technically. 2, we have a new component of the network called the Active Risk Management Network. The Active Risk Management Network was developed by a separate team at Chainlink Labs using different application architecture, different programming languages, different software libraries to minimize or eliminate any risk of a supply chain attack. So if there's a vulnerability in our architecture that hasn't been detected over the last 4 years, it's suddenly detected, the Active Risk Management Network is not vulnerable to that type of exploit. It's a completely separate system. Two, we have several built-in features to protect value in token transfers. So one is a token issuer can specify rate limits for a particular token and lane. And two, we can set rate limits in aggregate for total value of tokens sent over the network in any lane. And then Chainlink Labs does not own all the contracts. The owners of the contracts are the decentralized node operators, independent node operators that run the nodes that secure the network or run the network. Chainlink can propose changes, but the owners, again, which are not Chainlink Labs, can veto any change. And then lastly, the system is designed to favor safety over liveness. So the active risk management network, in addition to its proactive, I should say, in-process role of blessing Merkle-tree roots or making these proofs available, also proactively monitors the network and detects any sort of anomaly or abnormal circumstance and can place curses and pause the network if anything bad is detected. So CCIP can be used for all kinds of things. If you're just transferring tokens, payments, liquidity management, token transfers are a use case all by themselves. If you're using just the data or arbitrary message portion of CCIP, then cross-chain governance is an excellent use case. Also managing state across cross-chain apps, like cross-chain accounting, NFT projects that have components of the NFT on multiple chains, games that span multiple chains. And then programmable token transfers can be very useful for enterprises or traditional finance doing delivery versus payment or DVP type transactions, where payment is made in exchange for some sort of asset through an escrow contract that can be done cross-chain. And all kinds of cross-chain use cases are unlocked, whether it's cross-chain yield optimization, cross-chain lending, etc. That's it. I'm available if anyone has questions afterwards.
Thanks, Sam. So after that, we have a little bit about QiDao and what we're doing on CCIP, which it all begins with the single chain execution. So basically, what happens here is you have events happening on Ethereum, and these events can be propagated to other chains, the other deployments, using CCIP. So these changes could be triggered in a variety of different ways. You can use something like UMA as an oracle or reality.e, and basically pull the data from snapshot, execute it, show it in the multisig, and then transfer that payload to the different chains as we wish. And then the second one being multi-chain governance, which is way better and cooler from our perspective, as it allows us to be more flexible. Every hub, every deployment, so collection of contracts, is able to enact and push changes to the other deployments. Now, using some of the programmability that CCIP provides us, we can create a pseudo consensus algorithm that enables the different deployments to understand what a quorum is, how many votes are coming from each chain, and be able to then execute a change based on a time lock and give us a true kind of any chain working environment. And so the future role for Chainlink as well can be in very simple things like a ferry, so enabling people to kind of group all their all their cross-chain transfers to different chains, and basically be charged a lot less fees, or even free, subsidized by the protocol, but maybe at the cost of higher latency. And other things like consensus style things where you want to do a very custom circulating market cap on one chain, you can now use this to force that liquidity to be there on a specific chain, such as saying we're only going to provide X amount of bridge liquidity, which would enable X amount of capital to remain within the chain programmatically rather than enforced through a multi-sig. Yeah. Cool. Thanks. can check us out on my.finance and all the other links here.